Hi everyone, my name is Neha and this is the 13th lecture on electronic communications. In this lecture, we are going to learn about fiber optics basics. In traditional forms of transmission lines, twisted wire pairs or coaxial cables were used, and they were made up of copper wire, and they used to carry high power radio frequency signal over a short distance. They were excellent performers, but when we want to send the information over a long distance, for example, a group of telephone conversation, without using radio waves, then the conventional transmission lines are not the best choice. In that situation, we use fiber optics. So these fiber optics, they are the transmission lines designed to convey light signals instead of radio signals. In fiber optics, light wave acts as a carrier signal and is modulated with information before it's sent down to the cable. And on the other end, the light wave is demodulated and the original information is recovered. So the demodulation of the signal takes place at the receiver side, and the modulation of the signal takes place at the transmission side. Now in the fiber optics, the radio waves, as I said before, they are replaced by the light waves, which means the signal is going to be faster. Now let's see the definition over here. Fiber optics or optical fibers are long, thin strands of carefully drawn glass about the diameter of a human hair. These strands are arranged in bundles called optical cables. We rely on them to transmit light signals over a long distance. So here on the pictures you can see how the fiber optic cables it looks like, and these are the strands which are arranged in bundles in a cable. And here these are some examples of different types of fiber optic cables. Now next is applications of fiber optics. Fiber optic communication systems, they are being used more and more each day. Some of the applications I have mentioned over here. They are used in closed circuit TV systems, used in buildings for security, secure communication system at military bases. They are used in computer networks, wide area, metro and local area. In shipboard communications they are used in aircraft communication, in distributed antenna system they are used in, and there are many other applications like nuclear plant instrumentation, college campus communication, utilities, electric gas, and so on, station communications, connection between servers, routers, and switches in data centers. So there are multiple applications of fiber optics. Now next is fiber optic advantages. The first advantage here is the security. Fiber optic signals, they are very secure. It's hard to tamper with a fiber optic lines, and since signals are the light signals instead of the electricity, they are not affected by external source of noise. Let's also read here. It is very difficult to tap a fiber optic connection without causing a detectable disturbance on the line. So this is true. Now next is the immunity to EMI. They can work on a good harsh environment. They can work in the industrial, avionics, nuclear power plants, etc. Fiber optic cables, they do not radiate signals as some electrical signals do and cause interference to other cables. So that is the really good advantage of fiber optic cables. Now next here is low loss. So the fiber optic cables, they have a less signal attenuation over a given distance than an equivalent length of a coaxial cables. So therefore they have low losses compared to traditional cables. And we can read here, single mode fibers can carry signals for miles with little attenuation. So this single mode fibers we are going to see in the next lecture. Now next is the very wide bandwidth is available in the fiber optics. So in the frequency of the fiber optics cables, they they have a very high frequency, and due to which much more bandwidth is available on the fiber optic cables than compared to a copper line or the coaxial cables. And there are many other advantages of using the fiber optics. For example, uh, they provide the lighter weight because of the construction. They are made up of glass or plastic cables, which is much lighter in weight compared to the copper cables, and therefore this lightweight benefit offers a lot of advantages. For example, in your in the aeroplane, it's better to have a light-weighted communication system compared to the heavy cables. Now next is the fiber optic disadvantages, and it says fiber optics, they require special tools for connections and splicing. Splicing is not always possible on broken lines. So these fiber optics, they are sometimes difficult to work when compared with the copper transmission lines, and for these you need to require special tools. Now next here is expensive test equipment may be needed to verify operation. In fiber optics, it is impossible to measure the performance without specialized optical test equipments, and all the equipments which are used for fiber optics, they are very expensive. So these are the two disadvantages of fiber optics. Now next we have fiber optic construction and its operation. And it says fiber optic line, it consists of a outer jacket, inner cladding, and a central core, which you can see here in the picture, that this is the core, and at the outside of this core you have the cladding, and then the outer jacket is there. And this picture also shows the same thing. The inner side, this is the core, this is cladding, this is the jacket, and these are the reinforcing fibers. So here the outer jacket which you see, this protects the inner works from contamination by moisture and dirt, and it is made up of tough but flexible plastic. So when greater strength needed, the strands of reinforcing fibers, they may also be included inside the outer jackets. And next is this cladding. So this cladding, it basically surrounds the inner core, and there are two component function together to carry the light wave down the fibers. Core purpose is to carry the light, and it can be made either of transparent plastic or glass. Highest performing fibers, they use glass core, which provides much lower losses, and they have wider bandwidth also. And without cladding, if you don't have this cladding, some of the light would basically escape the core and on the way down to the cable, and resulting in the signal losses. Now next is fiber optic light source. So this fiber optic light sources, they use optical fibers as a light pipe, and they transmit light from a source through a fiber to a remote location. And there is another name of fiber optic light source, which is fiber optic illuminator. They are named by that as well. Now under that we have these two light sources, laser and the LED. So this laser, it produces a very narrow beam of light that is used in many technologies and instruments. You can see over here how the beam is very narrow, and the letter LASERs, these all, they have their own meaning, where L stands for light, A for amplification by simulated emission of radiation. So it is quite different from this type of laser. They are quite different from a light bulb or a flashlight. This type of light, it is useful for lots of technologies and instruments. For example, they can be used in precision tools. They can cut through diamonds or thick metals. They can also be designed to help in delicate surgeries. And if you know about the Curiosity rover, in that also it uses a laser spectrometer, and the function of laser spectrometer is to see what kinds of chemicals are in certain rocks on marks, and it take pictures of that. And next is the LED. LED is the light emitting diode, and they are basically the semiconductors that emit lights when an electric current passes through them. And when compared to lasers, they are inexpensive. Lasers are more expensive, and lasers are more powerful also, and they operate at a faster speed when compared with the LEDs. And laser, they can also transmit light farther with fewer errors when compared with the LEDs. Now next we have fiber optic light detectors. Under that we have phototransistors and photodiodes. Phototransistor, they provides DC gain, which simplifies receiver circuitry, and they are very slow. Their data rates are limited to less than 100 kb per second. And photodiodes, they require more complex receiver circuitry, provides no gain, but much more faster response they have, and their data rate is of 100 MB per second, and they are also popular by the name pin diodes. So all the photo transistor and photodiodes, they basically perform the same function. They receive incoming light and converted it to electricity. Phototransistor and photodiodes, they both can be used for sending the light, but the phototransistor is more sensitive in view of the gain provided by the fact that it is a bipolar transistor. And this makes phototransistor more suitable in a number of applications when compared with the photodiodes. So these were the two fiber optic light detectors. So this is the end of the lecture. Thank you so much for watching.